In the last class, we were discussing about the mechanically operated switches. That was the topic of the last class, where we stopped at the float type of level sensor. Okay, is the screen visible, students? Screen is you are able to see?
Yes, sir.
Okay. Next, we'll be studying the topic on sensors, various types of sensors. The sensors are the one which are meant to sense the applied input signal, or they detect the applied input signal, or they measure the applied input signal. So such types of devices, they are called as sensors. The sensors either sense the signal or detect the signal, or it is as good as measuring the signal. Such types of devices, we call them as sensors. These sensors, they convert one form of energy to other form of energy. The applied input signal may be mechanical in nature, it may be optical signal, it may be chemical signal, it may be magnetic signal, it can be pressure signal, it can be thermal signal, it can be any type of signal. This input signal, which is of one form of energy, is converted into an electrical energy. The sensor converts the applied input signal energy into electrical energy. Electrical energy means it can be either the current or the voltage. The sensors are classified based on the parameter they measure. Based on what parameter they are measuring, based on that the sensors are classified into various types. They convert mechanical, magnetic, thermal, optical and chemical variations into electric voltages and currents. Sensors are categorized by what they measure, and important point is they play an important role in the process manufacturing control applications. Process manufacturing control applications, the sensors are being used. First type of sensor that we are going to study is called as the proximity sensor. As I told in one of the classes, proximity means nearness, the distance, right? The distance between the target and the target object and the sensor. That is nothing but the proximity. Based on the distance, these sensors convert the sensed signal into electrical signal, and based on the electrical signal, they'll detect the presence of the object or the absence of the object. If the object is present, if the target object is present, then the nature of the electrical signal is different. If the target object is absent, then the nature of the electrical signal of the sensor is different. Proximity sensors or switches are pilot devices that detect the presence of an object. The object is usually called as target here, without the physical contact. This is important. There is no physical contact between the sensors and the object. Without the physical contact, without the object being coming in contact with the sensor, without the contact, it is able to sense the object and detect its presence or absence. These are solid state electronic devices. Proximity sensors are solid state electronic devices. Solid state electronic devices are nothing but the semiconductor devices. Semiconductor devices. The name semiconductor, it means that the conductivity of these materials or of these devices is in between that of the conductors and the insulators. In your PUC level, you might have studied conductors, semiconductors and insulators, right? Conductors are the one which conduct the electricity. They have high conductivity of electricity. Insulators, they don't conduct the electricity. For example, cardboard, paper, wood, they are bad conductors of electricity. Okay, so they are insulators. Then there are certain materials which have the conductivity in between that of the conductors and the insulators. Such materials are called as semiconductors. These solid state electronic devices are semiconductor devices. They are electronic devices. They are semiconductor devices which have the conductivity in between that of the conductors and the insulators. The name solid state has come to these devices because they are made up of solid state material. Previously they used what are called as vacuum tubes, right? For conduction of electricity, they use the what are called as vacuum tubes. Vacuum tubes, they made use of gaseous medium, gas medium, for the conduction of electricity. But later, as the technology advanced, there came the new type of devices, that is they were called as solid state devices. Okay, that is how they are called as solid state devices, because the medium is solid state. They are made up of solid state material, and hence the name given to these devices are solid state electronic devices. These solid state electronic devices are completely encapsulated in protective layer. They are encapsulated. These proximity sensors, they are encapsulated by protective layer, okay, protective sheath surrounding them, which avoids vibrations, shock, fumes, dust, air, humidity, right, corrosive agents, liquids, chemicals, whichever are found in the industry. If there are any of these unwanted materials, unwanted signals, maybe vibration signals or liquids, chemicals, corrosive agents. Corrosive agents are nothing but acidic agents, acids, right? If they are present and if they are damaging the proximity sensor, then that is avoided by the encapsulation that is provided surrounding this proximity sensors. These proximity sensors are used when the object to be sensed is having light weight, when the weight of the object is less, when it is soft, it is a soft object, and it is small. It cannot be used for large objects. Proximity sensor, it is used only for, it is meant to sense the objects which are of smaller size, which have light weight, and they are smaller in size. And these proximity sensors, they have rapid response and high switching rates. They have rapid response and high switching rates. Rapid response is the time to sense the object. How much time is necessary to sense the object? That is called as the response time. If it is taking more time to sense the object, to detect the object, then we say that response time is more. It is taking more time. If it is taking less time to sense the target object, then we say that the response time is less. Okay. High switching rates, the rate at which the sensor should switch between one object and the other object, or one object and the next object. For example, let us say we are using the proximity sensor for bottle counting application. For bottle counting application, right? There it has to count the number of bottles. When the first bottle comes, it will detect that. Then it has to immediately switch over to the next bottle. It should immediately switch to the next bottle, right? So the next bottle comes, again it will count that. So next bottle, there should be continuity in the switching, and also the continuity in the detection of the object. Okay, so this is the function of the proximity sensor, that it continuously switches while functioning, and it is able to respond faster for the detection of the objects. As in counting or ejection control applications. Ejection control, for example, your vending machine is there, coffee vending machine, or you can take Coca-Cola vending machines, right, where they eject the Coca-Cola tins, right? Coca-Cola tins they eject, right? And then based on how much they are ejecting, that means they have a certain speed. They eject the tin at a certain speed, right? So that is nothing but the ejection control application. So in such applications, these proximity sensors are used. An object has to be sensed through non-metallic barriers. These are designed in such a way that they are able to sense the objects even if there are any barriers in between. If there are in between the sensor and the object, in between the sensor, there is sensor on one side and the object on the other side, and in between, if there's any glass medium, any plastic medium, or any paper medium, if there are these barriers, then even if there are these barriers are present, the proximity sensor will function normally without getting affected, because it has been designed in such a way to overcome the different barriers. It has long life and reliable service, provides reliable service. Longer life is expected from every sensor, is it not? Because the longer it sustains or longer it is its life expectancy, then high reliability it has. We can easily rely upon a sensor which is having high life expectancy. If we say we purchase a sensor and which is going to say which is not functioning after 1 year or 1 year or so, then we say that it is not reliable. When do we say that it is highly reliable? If it functions for 3 years, 4 years, right? We purchase a cell phone, right? If it doesn't function properly, then 1 or 2 years, we say that is not reliable. If the cell phone functions say for at least for 4 years, 3 years, 5 years, then we say that it is good, it is reliable. We can rely upon such cell phones, right? This is what is called as the reliability factor. A fast electronic control system, this is also one of the points here. That is, it requires a bounce free input signal. The proximity sensor requires bounce free input signal. It means that whatever signal it has to sense, the proximity sensor is sensing some signal from the nearby object. This signal, if it bounces back, before the sensor, proximity sensor senses the signal from the object, if it bounces back to the object, then the proximity sensor is not able to detect the object, because it doesn't receive the signal which it has to sense for the detection of the object, for the detection of the presence of the object. And hence what will happen, it is unable to detect or the sense the signal here if it is bouncing. There are two types of proximity sensors here that we will be studying. One is called as the inductive proximity sensor, another one is the capacitive proximity sensors. These inductive proximity sensors, they are good enough to detect the objects which are of ferrous metals, that is containing the iron, or they may be non-ferrous metals such as copper, aluminum, brass. They detect both iron contained metals and non-iron contained metals, that is both ferrous metals and non-ferrous metals are detected by the inductive proximity sensors. The working principle on which the inductive proximity sensor works is that whenever there is a fluctuating current, fluctuating means AC current, then it induces an electromotive force in the target object. Okay, that means what? Whenever there is a current carrying conductor, we say that there is the force surrounding the current carrying conductor. Correct. When we bring any object near the current carrying conductor, right? Suppose we bring a magnetic object near the current carrying conductor, then it experiences a force. Correct. Whenever any object is brought nearer the current carrying conductor, it experiences certain force. And based on this principle, the inductive proximity sensor works. That is, there is a passing of the current, alternating current, AC current, and because of this, it gets magnetized. Whenever any material is brought near the, or the object, target object is brought nearer it, that will experience certain force, and thus the signals are reverted back or they are received back by the inductive proximity sensor. It will detect this signal and it will say that whether the object is present or it is not present. Next is the block diagram which shows the inductive proximity sensor. We'll see that this is the figure which is explaining the function of inductive proximity sensor. Here there is a coil, that is the inductance. Coil is nothing but the inductance. Okay, and when the current is passed through this coil, oscillations are generated by the coil and the oscillator arrangement. These two will make the generation of the oscillations, and these oscillations or the electromagnetic waves are sent from this portion of the inductive proximity sensor towards the object. There are electromagnetic waves that are generated. These electromagnetic waves are the waves which consists of electric field and the magnetic field perpendicular to each other. Okay, the electric field and the magnetic field are perpendicular to each other in the electromagnetic waves. Such of the waves we call them as electromagnetic waves. These electromagnetic waves are sent from this inductive proximity sensor towards the metal object, and when it hits the metal object, when the waves hit the metal object, they are reflected back and they are received by the sensor, proximity sensor, and inside the proximity sensor there is a part called as detector. This detector will detect the electromagnetic waves. Okay, the electromagnetic waves is reverted back. Then what will happen? Because the metal object is present, it has absorbed certain electromagnetic energy. It has absorbed certain energy that is from the input electromagnetic waves that is striking the object. It has absorbed certain energy, because of which the strength of the signal that is received at the detector is less. Whatever signal is received at the detector, that is less, because the object has absorbed certain energy from the applied electromagnetic waves. And this detector, when it detects that there is less energy, then it says that, or it identifies, or it detects that there is a presence of the object. Otherwise, if the received energy is same as the sent energy, then it says that, or it identifies, or it detects that there is no object present nearby. Okay, that is how the inductive proximity sensor works here. So if there is a presence of the target here, then it will detect that. Okay, and it will say that output is turned on. It will turn on the output because of the target present nearby the sensor. Okay, this is our proximity sensor. Target is present nearby, we are bringing it near. When it comes closer to this proximity sensor, here it is away. When it is away, the LED is off, or the indicator is off. But when the target is, or the object is brought towards the proximity sensor, it will sense that, and it will say that, it will identify, and it will turn on the output. It will turn on the indicator or the pilot light. Okay, oscillator circuit generates a high frequency electromagnetic field, or the electromagnetic waves that radiate from the end of the sensor. The electromagnetic radiations are sent from the sensor. When a metal object enters the field, when any object comes in the vicinity, in the nearby position of the proximity sensor, eddy currents are induced in the surface of the object. Eddy currents are the currents which are induced whenever any object cuts the flux lines. Any object cuts the flux lines here, when the object cuts the electromagnetic wave energy, then some currents are induced in the conductor, in the object. So such currents are called as the eddy currents. Okay, then the metal object strikes with the electromagnetic energy. There is certain small amount of current, or current loops are formed. Okay, loops are formed, or small current is induced in the object or the target material, and such currents are called as the eddy currents. Eddy currents on the object, their small magnitude is small, they are of not larger magnitude, their magnitude is less, magnitude of the current is less, and such currents are called as the eddy currents. Eddy currents on the object absorb some of the radiated energy from the sensor. What this object will do, it will absorb certain energy from the sensor, from the electromagnetic radiations, resulting in loss of energy and change of strength of the oscillator. That absorption of energy by the object will result in loss of the signal and changing the strength of the signal. The sensor's detection circuit monitors the oscillator strength. This detect will monitor the strength of the received signal and triggers a solid state output at a specific level. Solid state output means, again, the output is in the form of a on off. Here it is solid state. Here we are using the LED, solid state devices. So we are not using any gaseous medium. They are all solid state materials that we are using here, right? So this solid state LED or the indicator will be turned on. It's not a gaseous medium, it's a solid state device, and this solid state LED will be turned on, or the output device will be turned on. If the metal object leaves the sensing area, that is what I highlighted. If the metal object leaves the sensing area, then what will happen? There is no change in the strength of the transmitted signal and the strength of the received signal. Both are same. If so, then it says that the object is not present in the vicinity of the proximity sensor. The object is not present in nearby the proximity sensor. That is how it identifies. Once the metal object leaves the sensing area, the oscillator returns to its initial value, or it returns back to its normal state. Any difficulty up till here, students? Any difficulty up till here? Any questions? I hope everybody are following. Yes, students? Are you all here?
Yes,
Students?
sir.
Okay, following whatever I am explaining.
Yes, sir.
Okay, any difficulty, any problem in understanding up till now? Yes? Prasad? Hiramat?
Sir, no doubt, sir. Please, sir.
No doubts? Okay, right. Any questions as of now? Inoj, any questions?
No, sir.
Okay, we'll move ahead. Typical 3-wire DC sensor connection. Typical 3-wire DC sensor connection. Here it's a proximity sensor which is present with 3 terminals or 3 wires, wire leads. Okay, one is connected to the positive of the battery, Another terminal of the sensor is connected to the negative of the battery, and the third terminal is connected to the load. Load is any device which we want to supply with certain signal, output signal from the sensor. Okay, once it senses the object, we want to send certain signal output to the load. That is our load device here, whatever we have connected. This is normally open state. Normally open state means if the one of the terminal is connected to the positive, another terminal is connected to negative, as I have shown in the above diagram. One terminal connected to positive, another terminal connected to negative, and the third terminal connected to the load. This arrangement is called as normally open state. Normally open state of the proximity sensor switch. Okay. If suppose if it is not in the normally open state, if it is not in the normally open state, if it is closed state, normally closed state, then this terminal or this wire will be disconnected from the positive terminal, and we have the other way, that is one is connected to the load. Okay, and the signal, this will be reverted back. Actually, positive and negative will be reverted back. Okay, if the normally open state, then positive is connected to the upper portion, negative to the lower portion. If it is normally closed, then it is the opposite. Upper portion will be connected to negative, and the bottom terminal will be connected to positive. Okay. Majority of the sensor applications, they operate at 24-volt DC or 120-volt AC. The sensors that we are studying here, they usually operate at 24 volts DC signal or at 120 volts AC signal. The method of connecting a proximity sensor, it depends on the type of sensor and type of application. How we connect the proximity sensor, the way in which we connect the proximity sensor, it changes based on the type of sensor. For inductive sensor, the method of connection may be different. For capacitive sensor, the method of connecting may be different. Okay, and based on the application, if it is used for certain applications, different applications, field applications, based on the applications, the method of connection will be varying. The next figure shows a typical 3-wire DC sensor connection. The 3-wire DC proximity sensor has the positive and negative line leads connected directly to it. That is, positive is connected to upper portion, bottom portion is connected to the negative terminal. It is connected to negative of DC voltage here. Okay, that is this is meant to energize the proximity sensor. Why we are using this DC supply here? To energize the, that is, proximity sensor. When the sensor is actuated, the circuit will connect the signal wire to the positive side of the line if operating normally open. And next one is, this was a 3-wire DC sensor connection. DC sensor connection. Next one is the 2-wire proximity sensor connection. It is slightly different from the previous one. As you all can see in this, there is a series connection of the load to one of the terminals. One of the terminals is connected to the load in series, and the other one is connected to the positive. So one is connected to positive, another to negative. There are only 2 terminals here instead of 3. Okay, positive and negative. Positive to upper terminal, and through the load it is connected to negative of the terminal. Okay, or the negative of the battery, or the negative of the DC supply voltage. Such a connection is called as 2-wire proximity sensor connection. This is in the normally open state. If the terminals interchange, then it is called as normally closed state, NC connection. Normally open, full form is normally open. NO is full form is normally open. If it is normally closed connection, then we denote it as NC. NO for normally open and NC for normally closed. They are manufactured for either AC or DC supply voltages. 2-wire proximity sensor, they work for both AC supply voltages as well as for DC supply voltages. In the off state, enough current must flow. Suppose say the sensor is in off state, right? But if sensor is in off state, it should not completely go off. That means there should be some current flowing, some negligible current flowing through the sensor to keep it in active state. If it completely goes off, then it becomes very difficult to again turn it on. It takes some time to bring it back to its on state. And hence, to keep the switch, to keep the proximity sensor in the active state, some current should be flowing through the proximity sensor even if it is in the off state. And this current which flows through the sensor in off state, it is called as leakage current. This leakage current may be very less, it is hardly 1 or 2 milliamperes. Okay. In the off state, enough current must flow through the circuit to keep sensor active. This off state current is called leakage current and typically may range from 1 to 2 milliamperes. But if the switch is actuated, that is when it is energized, when we are applying the DC supply voltage, then it will get energized and normal current will flow through the proximity sensor and it will start to function, start to work. Next is the range of the proximity sensor. The next figure shows this one. Here it is showing the range of the proximity sensor. There is a target object here. There is a target object. Okay. And when this target object is nearer to the proximity sensor, in the region where the sensor can actually sense, that means the sensor will actually detect the object. It will detect the target material. That is called as the operating point. The point at which the object or the target material is actually detected by the proximity sensor in the region, in the vicinity of the sensor, is called as the operating point. There is a term which is called as hysteresis zone. The term is called as hysteresis zone. This hysteresis zone is, suppose the object is brought nearer to the proximity sensor. This is the object. You are bringing it nearer to the, this is proximity sensor. You are bringing nearer to the proximity sensor. When you bring it nearer to the proximity sensor, it will try to detect the object. It will try to detect the object or the target material. So at this point, what is happening? It is detecting. The sensor is detecting the target object. It is detecting the target object. Okay. So this point is called as the, that is, operating point, or the nearing point, nearby point. And when the object is excuse me, when the object is moved away from the, when the object is moved away from the, that is, sensor, then there is the sensor is not able to detect the object. That means there is a certain region, there is certain region surrounding the sensor, within which it is able to sense the object, or sense the target object. That region is called as the hysteresis zone. That region is called as the hysteresis zone. As you can see in this figure, this is the operating point at which the, this is a proximity sensor. The sensor is able to detect this target material, this target object, and here it is nearer to the proximity sensor. That is, this is the operating point. In the second figure that you all are seeing, the object is moved away from the sensor. The object is moved away from the sensor. That is, it is called as a release point. The first one, it is called as a nearby point or nearing point, and second figure what you are saying, it is called as a release point. The difference between this nearby point and the release point is called as the hysteresis zone. The difference between these two, it is nearby point, okay, or the operating point, and the release point is called as the hysteresis zone. Okay, that means it is a zone within which the sensor must operate. If it goes beyond this zone, the sensor cannot function. The sensor is not able to detect the object. This is the distance between the operating point when the target approaches the proximity sensor face, and the release point when the target is moving away from the sensor face. This is the distance between the operating point when the target approaches the proximity sensor face, and the release point when the target is moving away from the sensor face. The object must be closer to turn the sensor on rather than to turn it off. That is the point here. The object should be so much closer or so much nearer to the sensor that the sensor should be able to detect it. If it is not to that limit, if it is not to that range, then the sensor will not be in a position to detect the presence of the object. The target is moving toward the sensor, it will have to move to a closer point. Once the sensor turns on, it will remain on until the target moves to the release point. The sensor is in on state, it will continue to remain in the on state until the object is moved to the release point. Once it is moved to the release point, then it is away from the hysteresis zone, and hence the proximity sensor will be failing to detect the object. Hysteresis is needed to keep proximity sensors from chattering. When the object which is to be sensed by the proximity sensor is near to the, or it is in the region of the hysteresis zone, it is in the region of the hysteresis zone, then there is no sound being produced by this proximity sensor because of, say, any external vibrations, right? And then slow moving targets, or there is any external disturbances, electrical noise signals, temperature variations. Okay, if there are any external disturbances, if the object is within the hysteresis zone, then the then the if there are any external disturbances, those external disturbances are eliminated or they are avoided. Okay, if it is within the hysteresis zone. If it is outside the hysteresis zone, then the other factors will take upon the object, or it will take upon the working of the proximity sensor. Proximity sensors come equipped with the LED status indicator. There is an indicator on the proximity sensor which indicates the presence or absence of the object. If the object is present, the LED will be turned on, and if it is not, then the LED will be in the off state. Next, students, as I told, There are two types of proximity sensors. One is the inductive, other one is the capacitive type of proximity sensors. Both are almost similar. The difference is in the working of the inductive and capacitive sensors. In the inductive sensor, they make use of the inductance principle. That is, when the current flows, when the alternating current, fluctuating current flows through the coil, there is a force surrounding the coil, okay, or electromotive force surrounding the coil. Whereas in the capacitive proximity sensors, there is a storage of the electrostatic voltage. Okay, there is a storage of electrostatic charges in the capacitive proximity sensors when the object is nearby to these proximity sensors. And such type of proximity sensors, they are called capacitive proximity sensors. That is based on the nearness, distance of the object which they are going to sense, the capacitive voltage will change, or the amount of charges present on the capacitor will change, and this is used as the working principle to detect the nearby object. The main differences between the two types are that capacitive proximity sensors produce an electrostatic field. That means charges are static in nature. We know what is a capacitor, right? Capacitor is the one which stores the energy. There are two plates of the capacitor. As you have studied in your PU level, there are two plates of a capacitor, right? If you are connecting a DC voltage, if you are connecting a DC battery to the capacitor plates, one plate to the positive of the battery, another plate to the negative of the battery, then the charges will get deposited on the capacitor plates. One plate may be having a positive charge, another plate will be getting a negative charge. Correct? The charges are deposited on the plates of the capacitor, and this is called as electrostatic energy. Electrostatic charges. The charges are constant, they are not moving. If they are moving, then it is called as dynamic. Is it not? If the charges are fixed, they are not moving, they are stored on the plates, capacitor plates, and this is called as electrostatic. The meaning of static means fixed, constant, and electro means electric charges. Electrostatic, electric charges which are constant in nature, which are not moving. The main differences between two types are that capacitive proximity sensors produce an electrostatic field instead of an electromagnetic field and are actuated by both conductive and non-conductive materials. It also works for both conductive and non-conductive materials. This is the working of the capacitive proximity sensor. The capacitive proximity sensor has the plates, capacitive plates, capacitor plates, two plates. Okay. Then it has the oscillator to generate the oscillations. Now, when the object, this is a metallic or non-metallic object, the target, when it is brought nearer to this proximity sensor, right? Then because of the nearness of the object, the voltage or the charges present on the plates, capacitor plates will change. Okay, and because of this, the oscillations are generated or the voltage is changed, and these voltage change or the oscillators which are generated, that is sensed by this capacitive sensor, and it will identify whether there is a presence of the metallic object or the non-metallic object or not. If the object is not present, then the capacitor voltage will not change. It will remain fixed, it will remain constant. Okay, and the oscillations are also not generated. If there is no object, target absent, then this is how the oscillations are. They are not present, oscillations are not at all present if the target is absent. If the target is present, then there are oscillations. You can see the oscillations here in the region where the target is present. The above figure shows the operation of a capacitive sensor. Capacitive sensor contains a high frequency oscillator along with the surface formed by two metal electrodes. The surface of the capacitive proximity sensor consists of two metallic electrodes. When the target nears the sensing surface, it enters the electrostatic field of the electrodes. When the target nears the sensing surface, it is entering the electrostatic region or the electrostatic field region of the electrodes, and hence it changes the capacitance. The capacitance is changed. What is the equation for capacitance, students, in terms of charge and voltage? Equation of capacitance in terms of charge and voltage. C is equal to, try to recollect what you have studied in your first year. C is given by, C is equal to, what is the equation in terms of Q and V? C is given by Q by V. C is equal to Q by V. Is it not? This is the equation of the capacitance. Okay. So if the charge changes, then the capacitance changes. Okay. C is equal to Q by V. Q is the charge and V is the voltage. It enters the electrostatic field of the electrodes and changes the capacitance of the oscillator. As a result, the oscillator circuit begins oscillating and changes the output state of the sensor when it reaches certain amplitude. The oscillations will either increase or decrease depending on the presence of the object. If the object is present, you get oscillations. If the object is not present, there are no oscillations produced. And based on this oscillations, it is going to sense the presence of the object based on the certain amplitude levels of the oscillations. The amplitude of the oscillation is such a magnitude that it is able to, for that magnitude, it is able to identify the presence of the object. If it is to a particular magnitude of the oscillations, amplitude of the oscillations, the amplitude of the oscillations is less, then it means that the object may not be present. If the target moves away from the sensor, the oscillator's amplitude decreases and the switching will be brought back to its normal state, or the sensor will be coming back to its original state. Capacitive proximity sensors will sense metal objects as well as non-metallic materials such as paper, glass, liquids, cloth, etc. The range of these capacitor sensors is about 1 inch. That is, the capacitive proximity sensor range at which they detect the object is just 1 inch, regardless of the type of material being sensed. The material may be a metallic material or a non-metallic material, but the range is fixed. The object should be brought within the 1 inch range, then only the proximity sensor will detect the object. Otherwise, it is not able to detect the presence or absence of the object. The larger the dielectric constant, if the dielectric constant is more, we know the equation for the capacitance in terms of area of the capacitor plates, distance between the capacitor plates, and the dielectric constant. It is C is given by epsilon A by D. C is equal to epsilon A by D, where epsilon is the dielectric constant. Okay, A is the area of the plates, area of each of the two plates. Then D is the distance between the plates. There are two parallel plates like this. The area of the plates is A, the distance between the plates is D, and epsilon is the dielectric constant of the material with which the plates are made up of. Okay, if the dielectric constant is more, then the capacitance will be more. How? C is given by epsilon. What is the formula, students? Any idea? C is equal to epsilon into, anybody, any idea? Equation which relates capacitance to dielectric constant, area of the plates, and distance between the plates. Any idea what is the equation? You have studied in your PUC level. Do you all remember equation of capacitance? Yes, friends, do you all remember? C is given by epsilon A by D. C is equal to epsilon into A by D. Okay, where epsilon is the dielectric constant, or K is the electric constant. We are using K there. C is equal to Ka by D. K is the dielectric constant. A is the area of the plates, and D is the distance between the plates. Okay, if K is more, dielectric constant is more for the material of the capacitor plates, then, or the material of the object, then the capacitance will be more. Lesser the dielectric constant K, lesser will be the capacitance. Why? Because there is direct proportionality, is it not, between the capacitance and the dielectric constant. C is equal to K into A divided by D. C is equal to Ka by D. K into A by D. That means there is direct proportionality between capacitance and the dielectric constant. More the dielectric constant, more will be the capacitance. Lesser the dielectric constant, lesser will be the capacitance. Fine. This makes possible the detection of materials inside non-metallic containers. There is one example shown here, interesting example. As we can see here, these are the milk boxes or the milk containers, and we are using the proximity sensor to sense the boxes in which the milk is present. The proximity sensor should sense the boxes in which the milk is present. If they are empty boxes, then it should be moved away from the conveyor line. They are moving on a conveyor belt. Okay. If the box contains milk, then it will detect. If there is no milk present in the box, then that box is moved apart. It is separated. Okay, it is moved apart from the conveyor line. Let us see how it is done. The liquid has a much higher dielectric constant than the cardboard container, which gives the sensor the ability to see through the container and detect the liquid. That means inside the milk box, if it is a milk, the dielectric constant of the milk is higher than the dielectric constant of the outside cardboard box. Okay, because of this, what is happening? The capacitive proximity sensor will sense the milk because it is having more dielectric constant. More the dielectric constant, more will be the capacitance. According to the equation, C is equal to Ka by D. Right? Because of this, it will is able to sense the presence of the milk inside the box. And if the milk box is empty, if the box doesn't contain milk, then it is moved away or separated from the conveyor belt line. Okay. In the process shown, detected empty containers are automatically diverted via the push rod. There is a rod which pushes off the empty containers, empty milk boxes away from the conveyor line. Inductive proximity switches are insensitive to humidity, dust, dirt, and other such materials. The inductive proximity sensor difference, one of the important difference between inductive proximity sensor and the capacitive proximity sensor is that inductive proximity sensor is insensitive to the dust, to the dirt, to moisture, is insensitive to all these materials, whereas the capacitive proximity sensor is sensitive to the dirt in the environment. That means if there is any change in the dielectric constant of the dirt, then that is going to have an impact on the capacitive sensor, and the capacitance voltage changes, and thus it may not be in a position to identify the nearby object, or it may so happen that it may faultily detect an object. If the object may not be present, if the dirt is present, instead of the object may detect the dirt and say that this is the object, or this the object is present. It may so happen. Okay, so it is not so much reliable. Capacitive proximity sensors are not that much reliable as that of the inductive proximity sensors. Okay. Next topic, students, about the magnetic reed switch. The question that may appear on the proximity sensors is, explain the various types of proximity sensors with necessary figures. That may be the possible question on the proximity sensors. Okay, maybe asked for 8 or 10 marks. Okay, you have to explain in detail by drawing necessary figures about the proximity sensors. Next, magnetic reed switch. This magnetic reed switch, it consists of two flat contact tabs or two flat surfaces. This is how the magnetic reed switch looks like. This and this. Okay, what you're seeing on the left side and what you're seeing on the right side, they are flat tabs. They are flat surfaces. Okay, flat slabs or flat tabs or flat surfaces. They are called as reed. They are called as reed. Okay. Now, when the magnetic material is brought nearer this sensor or the magnetic reed switch, then the flux lines will be cutting this reed switch because of the nearby magnet. Because of the presence of the nearby magnet, there are flux lines, magnetic field lines, and these flux lines of the magnetic field lines, they strike or they cut the magnetic reed switch. They are present on these tabs, or they are present on these surfaces, two surfaces. Okay. Because of this, what will happen? These two tabs or these two surfaces will act like magnetic poles, and they will attract each other. If the strength of the magnetic field, strength of the magnetic flux lines is so high that if these two contacts, if these two tabs, they attract each other, then the switch will operate. Okay. And the switch will get actuated. The switch will get actuated, energized, and it will function in order to detect the presence of the nearby object. Okay. A magnetic reed switch is composed of two flat contact tabs that are hermetically sealed. Hermetically sealed means it is completely airtight. There is no air present inside. It is vacuum. In a glass tube, as illustrated in the next figure, when magnetic force is generated parallel to the reed switch, the reed becomes flux carriers in the magnetic circuit. The flux lines will be passing through these two flat surfaces. The overlapping ends of the reeds become magnetic poles which attract each other. The poles, that is the slabs, these two slabs, they become magnetic poles and they start attracting each other. They are attracted towards each other. Because of this, what is happening? The switch gets actuated. It is connected in such a mechanism that it gets actuated and is able to sense the presence of the object because of this principle or because of this mechanism. If the magnetic force between the poles is strong enough to overcome the restoring force of the reeds will be drawn together to actuate the switch. Because the contacts are sealed, again here the contacts are sealed in a vacuum, and hence it is not affected by any dust or humidity or moisture or chemicals, right? Okay, it is unaffected by these materials, fumes, and hence its life expectancy is high. Because it is not affected by any external materials, the life expectancy of the magnetic reed switch is high. Next, students, this is the working principle of magnetic reed switch. The possible question that may appear on magnetic reed switch is that explain the working principle of the magnetic reed switch. Just you all have to draw this figure and explain the working principle. We ask for just 4 marks question. Next is the light sensors. Okay, which is the light sensor that we have already come across in module 1? Do you remember in module 1 the light sensor which we came across? Yes, please. Any light sensor do you remember in module 1?
Photodiode.
Photodiode, very good. Phototransistor, yes or no? In which topic we came across this? Can you recollect your test question? Higher test question. In which topic we come across this phototransistor? We have come across this when studying the topic on IO modules, right? We studied the IO modules, is not schematic diagram. Okay, complete schematic diagram, right? Okay, we understood how the signal is sensed, how it is rectified from AC to DC, how it is converted from analog to digital, right? Correct. So there we studied in IO modules. When the study of the IO modules, we came across that is photo transistors. Okay. There are two types of light sensors. One is called as the photovoltaic cell and the photoconductive cell. These are the two types of light sensors. One is called as photovoltaic cell, another one is the photoconductive cell. Photovoltaic cell is the one which converts the input light energy into voltage, or it converts light energy into electrical signal. Such a sensor is called as photovoltaic cell or the photovoltaic sensor. The photoconductive cell is the one which converts the light energy into change in resistance. The input light energy is converted to change in resistance. Resistance changes. And such of the sensors, they are called as photoconductive cells. The photovoltaic or solar cell reacts to light by converting the light energy directly into electrical energy. The photoconductive cell, also called a photoresistive cell, another name, alternative name for photoconductive cell is photoresistive cell. This converts change in light energy to change in resistance. It reacts to light by change in the resistance of the cell. This is the figure which shows the photoelectric sensor. This is what you are seeing is the LED. Okay, the photoelectric sensor consists of the LED in the transmitter portion, LED and the oscillator. Okay, the oscillator will control the light intensity of this LED, and this light energy is sent or it is transmitted to the object. It is transmitted from the LED towards the object, right? Then the light strikes the object. When the light energy strikes the object, it is reflected back. It is modulated light beam or reflected light beam, and then it falls on the receiver portion. Receiver portion, what it does, this converts, it's a phototransistor which converts light energy into electrical energy, and the output electrical energy may be used to drive the load, or it may be used to apply to the output load which is connected at the end of the receiver. Okay, this is how the photoelectric sensor works. Photoelectric or the photovoltaic, both are one in the same. Photoelectric means converting light energy into electrical energy. Photovoltaic is nothing but converting again the light energy into electrical signal or the voltage signal. Photovoltaic and photoconductive light cells. In the first figure that you are seeing is a photovoltaic solar cell. It is called photovoltaic solar cell or the photovoltaic cell. Here it is converting the applied light energy. This is the figure how it looks like physically, the photovoltaic cell. Okay, this diagrammatically it is shown like this, symbol wise, symbolically. It is converting the light energy into electrical energy. And what happens here, because of conversion from light energy to electrical energy, what is happening here? Yes, the light energy is converted to electrical energy. Because of this, what is happening in the circuit? What will pass in the circuit because of conversion from light energy to electrical energy? Yes, please.
Sound.
What will pass? Light energy is converted into electrical energy. What is electrical energy? Yes,
Current.
Current, is it not? Current or the voltage. So the current will pass through the circuit here and will be able to see the voltage on this digital multimeter. Okay, it's a multimeter. Multimeter means which shows the voltage, current, resistance. Okay, all values you can see on this meter. Such a meter is called as digital multimeter or some meters. Similarly, in the next figure, this is the physical appearance of the photoconductive cell or the photoresistive cell. This is how it looks like, and symbolically it is represented like this. So this variable resistance, it is indicated like this, means with the circle surrounding it, it indicates that it is a photoresistive cell or a photoconductive cell. When the light falls on this photoconductive cell, there is change in the resistance of this photoconductive cell, and because of this change in resistance, we are able to find out how much is the change in resistance on this meter. If there is change by 5 ohms, then we are able to see that initial value of resistance was this much. Now the final value of the resistance is this much, right? We are able to identify the change in resistance by the help of this digital multimeter. Okay, this is how the first figure is for photovoltaic and the second one for the photoconductive light cells or the light sensors. Based on how much voltage it is producing, it is able to sense the amount of light energy. Both are directly proportional to each other. If light energy is more, the converted light energy to electrical energy is also more. If light energy is less, electrical output is less or electrical output voltage is less. Both are directly proportional to each other. Based on this, they are correlated and they are calibrated in such a way that the output voltage what is measured, that will measure in turn the light energy that is incident on the photovoltaic cell or the light energy which is incident on the photoconductive cells. A photoelectric sensor is an optical control device that operates by detecting a visible or invisible beam of light and responding to a change in the received light intensity. It responds to change in intensity of the light energy. Photoelectric sensors are composed of two basic components, that is transmitter portion and the receiver portion. Transmitter portion is the light source or the LED, light emitting diode, which will emit the light energy, and the receiver portion is the sensor. These two components may or may not be housed in separate units. There are two types of again photoelectric sensors. In one of the photoelectric sensor, both the transmitter and receiver are present in the same house. They are present in the same compartment. Okay. Whereas in the other type, the transmitter is in different compartment and the receiver is in different compartment. Both are separate. Okay. Let us look into the details of these. The basic operation of a photoelectric sensor is summarized like this. Operation of a photoelectric sensor. The transmitter contains a light source, an LED, along with the oscillator. This transmitter portion, it contains the light source and an oscillator inside here, inside this house, which it is consisting of transmitter and receiver. Oscillator modulates that or turns on the LED on and off at a high rate of speed. The function of the oscillator is to turn the LED on and off at a higher speed. Because of this, what will happen? As it is turned on and off at a higher speed, the light energy is emitted out. The light energy is coming out of the light emitting diode or the LED. The transmitter sends this light energy to the receiver. The receiver, it decodes this light energy and switches the output device. It receives the light energy and it is able to turn on the output field device. Here the receiver, it senses or it is tuned only to a particular frequency of the transmitted signal. Like how we have the radio sets, right? Now radio set, what we are doing? We are turning on to a particular FM station, right? Particular FM station. So when we turn on to a particular signal, we turn the knob, right? We are tuning that frequency to the frequency that is transmitted from the transmitter antenna. Okay, that means both are in synchronization. Both are in synchronization. Both are at the same frequency. We are tuning. Tuning means the receiver is able to sense only that signal which is sent by the transmitter, and it avoids or it eliminates the other signals. This particular process is called as tuning process, right? The receiver is tuned to its emitter modulation frequency and it will only amplify the signal that has the frequency that is sent by the transmitter. Whatever signal frequency is sent by the transmitter, the receiver will tune to that particular frequency, and if it receives that signal frequency only then it will amplify the signal for further processing. Otherwise, it will reject the signals. Most sensors allow adjustment of how much light will cause the output of the sensor to change the state. Response time is related to frequency of the light pulses. If the frequency is high, response time is high or less. If frequency of the light pulses is high, response time will be, frequency is inversely proportional to time. F is equal to 1 by T. Correct? F is more, time will be less. Inversely proportional. Frequency to time period. If frequency is less, time period will be more. If frequency is more, time period will be less. Time taken, response time will be less. Next is what is called as a through beam scanning. It's related to photoelectric sensors only. It is called as through beam scan. Let us look into the details of this through beam scan. This is how it appears. That is, transmitter and the receiver portion are placed on a single line. Okay, the transmitter and the receiver portion are placed on a single line. That is, the transmitter sends the light signal and the receiver is able to receive it on parallelly on a single line. Okay, so such of the arrangement is called as through beam scanning. And the object will be placed in between here. In between the transmitter and the receiver, the object is placed. Okay, there is distraction of the signal or interference of the input signal, and again it is transmitted back to the receiver. Receiver will receive the signal. As the object which is in between transmitter and receiver absorbs certain energy, the received energy will be less, and hence it will be able to detect the presence or the absence of the object. The through beam scan technique, it is also called as direct scan technique, places a transmitter and receiver in direct line with each other as shown in the figure. Because the light beam travels in only one direction, through beam scanning provides long range sensing. The light travels in a single path, single line, and hence this scanning process is used for long range sensing of the objects. Example of through beam scanning is the garage door. Right? Nearby the garage door, this that is through beam scan technique, sensors and the receivers are used. Receiver and the transmitter are used. Okay, when it is placed there nearby the garage door, it will sense the opening and closing of the door. If the door is opened, right, the received signal will be different and it will indicate that the door is opened. Strength of the received signal is decreased because the door has opened. The door has closed. The strength of the transmitted signal is same as the received signal, so it will indicate that the door is in closed position. One more type of scanning, it is called as retroreflective scanning. Retroreflective scanning. This is different from the previous one. Here, transmitter and receiver are placed on the same housing. In the same compartment, both transmitter and receiver are placed. In the previous one, through beam scanning, how it is, transmitter is different, receiver is different. They are placed in two different compartments, in two different houses. But for the retroreflective scanning, the transmitter and receiver are in the same portion. They are in the same house, same compartment. Transmitter will transmit the signal. There is a portion called as reflector here. So this reflector portion will reflect the transmitted signal, and the object is placed in between the transmitter and the receiver. Okay, because if the object is present in between the transmitter and the receiver, it will absorb certain energy, it will get reflected from the reflector and it is received back. The received energy is less as compared to transmitter energy, and hence we say that the object is present in the nearby of the sensor or nearby the sensor. Okay. In retroreflective scanning, the transmitter and receiver are in the same enclosure. This requires a separate reflector. The disadvantage of the retroreflective scanning is that a separate reflector is needed here, as shown in this figure. But in the through beam scanning, there is no reflector required. The retroreflective scan is designed to respond to objects that interrupt the beam normally maintained between transmitter and receiver. Next, we move on to one more interesting topic, that is fiber optic sensors. In the fiber optic sensors, the fiber optic cables are used. Okay, all of you are familiar with the fiber optic cables nowadays, optical fiber. Okay, so these optical fibers, basically they work on the principle of total internal reflection. It is called TIR, total internal reflection. It means that the signal which is transmitted at the transmitting end of the optical fiber. Okay, it is transmitted through the optical fiber. It is reflected internally because of the refractive indices. Because the refractive indices of the cable are arranged in such a way that it undergoes total internal reflection. When mu1 and mu2 are different, okay, there is possibility of the incident ray getting refracted. It's called refraction principle, which we might have studied in your PU level again. Okay, so that is a refraction principle. If the refractive indices are different, it may so happen that the incident ray may get reflected or it gets refracted. Refraction, it passes through the other medium from medium 1 to medium 2. But if the refractive indices are arranged in such a way that, okay, there is total internal reflection, it remains in the same medium, it doesn't go to the second medium. Okay, from it doesn't move from first medium to second medium or from first medium through to the second medium. It gets reflected within the same medium, and this principle is called as total internal reflection. That is the working principle of this optical fiber cables. This is shown in the next figure, the functioning of fiber optic sensors. This is a fiber optic sensor which is radiating the light energy. Okay, and if the object is present, then it will identify that there is no light or less light incident on the receiver because of the presence of the object, and hence it identifies presence of the object. If the object is not present here, suppose in between this bottle and this bottle, okay, there is no object, so there is direct light incident from this optical fiber to the receiver, right? That is, transmitted light is same as the received light. There is no change in the intensity or the strength of the received signal, and hence it identifies that there is no object. Suppose if object is present, there is change in the strength of the received signal, and hence it identifies that the object is present. These sensors, they are completely immune. One of the important property of the fiber optic sensors is that they are immune to electromagnetic noise or electromagnetic interferences. If there's any nearby cable nearer to this optical fiber, and if there's any noise signal from that cable to this cable, that is not affecting the fiber optic cables. Okay, this is one of the important property of the fiber optic cables. That is why in recent applications the optical fibers are used, okay, instead of the normal cables, because it is not getting affected by the noise signals, nearby electromagnetic noise signals or electrical noise signals. And it does not contain any moving parts also. There is no moving parts. In the previous sensors we saw photoelectric sensors, there was transmitter, receiver. Okay, here it does not consist of any moving parts as such, and hence spark is avoided. If there are moving parts, so what will happen? There is a friction caused between the parts of the sensor, is it not? But as there are no moving parts in the optical fiber system sensors, and hence the spark is not present in this particular sensor, and hence it can be safely used in most of the hazardous conditions, such as in refining applications, mining applications, pharmaceutical applications, chemical industries, manufacturing industries. These are few of the applications of the fiber optic sensors. The next one is the PLC barcode application. Again, it's one of the light sensor, PLC barcode. Now we have visited to few of the shops, right, and where they scan the barcode present on the item. Suppose if you go to buy certain item, grocery item or any other item, okay, right, then they scan the barcode which is present on that item. Now on that item, whatever is the barcode present, that consists of the bars and the spaces in between. All of you have seen the barcode, right? Yes, I hope everyone are aware of barcode. Everyone have seen the barcode on the items. Yes, have you all seen, students, barcode on the items?
Yes, sir.
Okay, fine. Yes, So these barcode, they will be having bars on them, and in between there are certain spaces. Now the bars which are present on these barcode of that item, they will absorb the light energy which is incident on it. When you apply the scanner, light energy from the scanner will be incident on the bars, and wherever it is incident on the bars, the light energy is absorbed. And when the same light energy, when it is incident on the spaces, in between spaces, that is empty portion, it gets reflected from there. It gets reflected, it is again returning back to the sensor, and it will decode that, and it will convert that light energy received into in terms of characters. It will convert it in terms of characters. Okay, so that is the light energy, maybe IR energy, infrared light energy. Say, let us say it is present on the barcode. It strikes the bars, light energy is absorbed. Wherever there are spaces, empty portion, the light is reflected. The light is reflected back. It is received by the receiver, and this received light energy is converted into form of text, or it is converted into form of characters. Then you'll be able to see the how much is the price of that particular quantity. Correct. So this is how it is decoding the light intensity that is received by this barcode scanner in terms of characters or in terms of text. So this is implemented in industry to enter the data quickly and accurately. This is nothing but regarded as the eye of the data collection system. It is called as the eyes of the data collection system, because it is becoming so much prominent nowadays that we are relying very much on this barcode scanner, because it avoids the manual work. Manually, if you want to see the rate and enter the rate in your database, it takes more time on your desktop. But if you are looking into the barcode, and automatically it takes the rate of that, and we will be able to proceed to the next item quickly. A light source within the scanner illuminates the barcode symbol. Those bars absorbs light and spaces reflect light. A photodetector collects the light in the form of an electronic signal pattern representing the printed symbol. The decoder receives the signal from the scanner and converts these data into the character data representation of the symbol's code. Next figure illustrates a typical PLC application which involves a barcode module. This is how it is, the block diagram of PLC barcode application. This is the barcode scanner or the decoder, right? This is a programmable controller PLC. Okay, so based on the barcode, if the object is present here, it will sense that the output of the barcode scanner is applied to the PLC. Then what this PLC will do, it will energize this diverter. If the object is present, then the PLC will not energize the diverter. Or say if the many different objects are coming, let us say there are different types of objects on a single conveyor belt. Okay, if you are considering the same type of object on the single conveyor belt, then there is no problem as such. Okay, now what is the problem here is many items, variety of items are coming on a single conveyor belt. Then we have to separate these items. Suppose say there are two items, mixture of two items on the single conveyor belt. I have to separate these two. Now to separate these two, what I am doing, I am sensing the barcode of these items by the scanner, and based on this I will output to the PLC. Right? The PLC, what it does, it senses the particular signal from the scanner, and based on that it will activate this diverter. What this diverter will do is mechanically it is going to separate out the items. If the first item is having higher light energy received, then it may separate it out. If the light energy received from the second item, it is continuing on the same conveyor belt, something like that. Okay. PLC is then used to divert the boxes to the appropriate product lines according to the data read from the barcode. Next are the ultrasonic sensors. These ultrasonic sensors, we are very much familiar of the ultrasound signal. Again, you have studied in your physics in your first year level. Okay, ultrasound signals. What is the speed of the sound signal, students? Do you all remember speed of the sound signal? How much is the velocity of the sound signal?
Greater than the speed of the sound.
No, that is fine, but they are employing the sound signal only here, ultrasonic signal. It is fine. You are answered correctly. But the sound signal, when they are employing, what is the velocity of the sound signal? Normal sound signal. Its velocity is how much?
3.8 meter per second.
343 meters per second. Velocity
Yes,
of
sir.
the sound signal, it is
Yes.
343 meters per second. Is it not? Velocity of light signal, light velocity is how much? Speed of light in
3
vacuum.
into 10 raised to 8.
Yes, 3 into 10 raised to 8 meters per second. You are right. An ultrasonic sensor, it operates by sending high frequency sound waves towards the target and measuring the time taken to reflect back. Ultrasound signals are transmitted from the transmitter, okay, high frequency signals. It reflects from the object which it has to detect, and then the reflected signal received by the receiver of the sensor. It will check how much is the time taken for the transmitted signal to be received back. This particular principle is called as transit time. Transit time means how much time it is taking for the ultrasound signal transmitted from the sensor to be reflected back from the object and received at the sensor. Based on the transit time, it will identify what is the distance of the object and which object is present. Based on the quality of the received signal, strength of the received signal is able to identify the presence or absence of the object, and also it identifies what is the distance of the object from the sensor. Okay. And one of the other principle that may be used is a change in the velocity of the signal. If the velocity of the signal changes, the transmitted signal velocity and the received signal velocity, that principle is also used sometimes. That is called a change in velocity. If it is the principle used is change in timing or transit time, then it is called transit time principle. If it is based on the change in velocity of the signal, it is called as change in velocity principle of the ultrasonic sensors. The time taken for this echo to return to the sensor is directly proportional to the distance. This is important. If the distance is more, time taken will be more. They are directly proportional. Distance between the transmitter and receiver, if it is more, or the object distance is more from the transmitter, then what will happen? The time taken will be more. If the distance is less, time taken will be less. Correct? The next, that is, we are going to take up that in the next class. Practical application in which the returning echo signal is electronically converted to a 4 to 20 milliampere output signal. Here what is done is, the object, okay, if it consists of empty liquid, that means there is no liquid present. If the object is having, if the container has no liquid, empty, it is empty, then that is calibrated to be 4 milliampere. In industry is calibrated as 4 milliampere. That means the distance will be the empty portion, distance is near, or it is the bottom portion, so distance is greater. Okay. And if it is, the tank is full, it may so happen that the distance is less from the object top portion to the sensor. Okay. So because of this, what is happening? Change in distance, right? The sensor is able to identify whether the container is empty or whether it is full. Whether the container is empty or it is full, right? That means if the received signal, electrical signal, after converting the sound signal to electrical signal, if it is say 4 milliampere, that it indicates that the tank is empty or the container is empty. If the received signal, that is converted from sound energy to electrical signal, once the sound energy is received by the sensor, it converts that into electrical signal. If this electrical signal is 20 milliampere, it means that the tank is full or the container is full. The sensor will proportionately generate a 4 milliampere signal when the tank is empty and a 20 milliampere signal when the tank is full. So these ultrasonic sensors can detect the solids, fluids or liquids, granular objects, granules, right, textiles. Okay. And they are able to detect different objects irrespective of the color. Irrespective of the color of the objects, they are able to sense and detect those objects, and hence they are ideal for monitoring the transparent objects. the transparent objects. So those transparent objects will be detected easily as compared to that of the opaque objects. Okay, because in the opaque objects, what will happen? There is certain absorption of energy. The transparent objects, the reflection will be more, the absorption of energy will be less, and hence the ultrasonic sensors are more ideal for monitoring or for sensing the transparent objects. Okay, so some questions may be asked on these applications of light sensors. That is, explain the various light sensors used in PLCs. Okay, that may be the possible question on this topic. In today's class, students, we have gone through various topics, starting from sensors. What is a sensor? Its definition. Okay, sensors definition. And then we have taken various types of sensors, starting from proximity sensor. What is a proximity sensor? What are its features? How does it work? Working principle of inductive proximity sensor. Then later, wire DC sensor connection diagram for the inductive sensor. Then two-wire proximity sensor connection. Then later, we explained the sensor range, considering the hysteresis zone, okay, operating point and the release point. Capacitive proximity sensors. The difference between capacitive proximity sensor and the inductive proximity sensor. We explained the points about that. Then application of capacitive proximity sensor to sense the milk contained in the container, to identify empty milk containers, empty milk boxes. Then magnetic reed switch, the diagram and explanation of magnetic reed switch. Light sensors, various light sensors we have gone through. The one of those is photovoltaic or photoelectric sensor. We have studied the working principle of this sensor. Then photovoltaic and photoconductive light cells. What is meant by photovoltaic cell? What is meant by photoconductive cell or photoresistive cell? Okay. Then various features of photoelectric sensor, how it works, working principle. Two beam scanning, that means both the transmitter and receiver are on the same line, direct line with respect to each other. Reflective scanning, in which there is a reflector present in between the transmitter and the receiver. Okay, but in through beam scanning, there is no reflector present. That is the difference between the through beam scanning and the retroreflective scanning. And fiber optic sensors, one of the advanced technology, okay, which is immune to electromagnetic interferences, which operates with the principle of total internal reflection. Its applications to count the bottles or to detect the presence of the bottles on the conveyor line, conveyor belt. Then another application of the light sensor is PLC barcode application, which scans the bars and the that is spaces. Based on this, it identifies the object and its application here, considering this diagram. Then the ultrasonic sensors. What are ultrasonic sensors? And they work on the principle of transit time or change in velocity, and its application to detect the empty tank or the empty container and the full tank or the full container. Based on empty tank, it generates 4 milliampere signal. If it is full tank, then the signal that is generated will be 20 milliampere signal. This is how it is calibrated. Okay. So that's all, students. If there are any questions from your side, you all can ask. Any questions, students, here? Malik Rian Sheikh, no questions. Okay. Praveen Helvi, Praveen,
No, sir.
no questions. Chetan Patil understood today's topics. Chetan Patil, Chetan. Okay. Nemani Patil, any problem
sir,
in
no.
understanding? Understood. Okay. Any questions, Nemani Patil? Any questions? Okay.
No, sir,
Fine.
no.
Okay. Inoj, any questions? Anything not understood? Inoj?
No, sir, understood.
Okay. Then
Sir, I think my So
No problem.
attendance is not taken, I think, so my.
No, it is taken,
Okay.
Inoj. I have given your attendance. I have given. It's not taken. I will mark it then.
Okay, sir.
I'll mark it. Okay, fine. Then one thing I wanted to ask you all here: when shall we conduct extra classes? I wanted to take some extra classes. When shall we conduct? When you all want me to take the extra class? At least for 1 hour or 1.5 hour like that.
Take morning class.
Morning. What time? Timing? Your classes start at 8:30, right?
No, sir. It start at 10:30. You can take it 8:30, sir.
Every day it is starting at 10:30 for you all. Okay, okay,
Yes, sir.
okay. But my this thing schedule is I have class morning 8:30 on every Tuesday, Wednesday I am having for you all, Thursday and Friday. Only Monday and Saturday I don't have morning classes. Monday, Thursday also I am having morning class. Tuesday, Wednesday, Thursday, Friday I have morning class. Only Monday and Saturday.
Yes. Saturday you can take, sir.
Saturday I will take. Shall I take? Okay, morning class. Then I'll inform you all the timing on this Saturday, coming Saturday. Okay, shall we take at 8 or 8:30 like that?
Okay, sir.
Saturday?
Okay, sir.
Okay, I'll inform you all the timing. Okay, fine. Okay, students, thank you.